Welcome back, super friends, and thanks again for joining Miss Choice on another math video. Today we are going to focus on classifying quadrilaterals. Quadrilaterals are any closed four-sided figure. So we're going to discuss that. You'll need your math notebook, you'll need a pencil to write with, and of course, you'll need that super brain of yours. Stay tuned for the video. All right, super friends, let's get started with this lesson of classifying quadrilaterals. Let's go over our vocabulary. Remember, any vocabulary or any notes that we go over during the videos, I would like for you to write down. That way you can refer to them when you actually start answering questions. So, first vocab word is parallelogram, and it has two pairs of parallel sides. What that means is that the top side the top side is parallel to the bottom side, meaning that if they keep going on and on and on and on and on, they don't touch. Just like the right side is parallel to the left side. If they keep going on and on and on and on, they never touch. So that's what parallelogram means. It has two pairs of parallel sides. Rectangle has four right angles. So right angle, right angle, right angle, right angle. And it is also a parallelogram because the left side and the right side are parallel to each other, and the bottom and the top are parallel to each other. So it has four right angles and two pairs of parallel sides. So a rectangle is a parallelogram. A square is a very interesting, unique shape in the fact that it has four right angles and all sides are the same length. So square means that this side is the same as this side, is the same as this side, is the same as that side. They are also parallelogram because the top line and the bottom line are parallel to each other, and the left line and the right line are parallel to each other. Now, they also have the right angles inside because these are perpendicular lines, right angles, right angles. It's a parallelogram, a rectangle, and a rhombus. The reason why it's a rhombus is because, let's look at the rhombus. A rhombus is a quadrilateral that has opposite sides that are parallel and all of its sides are the same length. So just like a rhombus, the square has all the sides that are the same length, and a rhombus has all the sides that are same length. But the only difference between a rhombus and a square is that there are no right angles in the rhombus. The square has right angles, that's why it's a square. Rhombus does not have right angles. Rhombus has obtuse angles and acute angles. That's why it is a rhombus. Lastly, we have our trapezoid, which is also another quadrilateral, and it is only one pair of parallel sides, which is going to be the top and the bottom side. So that means that this is always parallel. Now, you might see a trapezoid that is like standing upright, like on its side. Like if you were to lean over, it would be that way or that angle, and it's still a trapezoid. It just only has one pair of parallel sides. So it could sometimes be that the left and the right sides are the parallel sides, but it's still just one set, and that's what makes it a trapezoid. So please use this information when it comes to answering your questions. This first question says, write all names possible for the quadrilateral. Choose the answer below. So looking at this picture, we see that this is a trapezoid. So obviously we need something that has a trapezoid in it. This one's the only one that has that. Remember, parallelograms means that you have two sets of parallel sides, or not even two sets, but all the sides are they each have parallel sides to it. So this would be parallel to this one if it was a parallelogram, but it's not. If I were to keep going with these lines, they would end up touching and make like a triangle basically. These, though, the top and the bottom lines, they are parallel to each other because they won't end up touching at all. They would just keep going in opposite directions the whole time. So let's check our answer. We are correct. Okay, now for this one, it says write all the names possible for the quadrilateral. Obviously, this is a square. A square can be a whole bunch of things because it is a very versatile shape. So this line, the left and the right lines or sides are parallel to each other, meaning that they won't ever touch, just like the top and the bottom lines are parallel to each other, meaning that they will never touch. So I know it's a quadrilateral because it's a four-sided figure that is closed, meaning that there's no openings to it. I know it's a parallelogram because all the sides, the opposite sides, are parallel to each other. A square can also be a rectangle because it means that two sides are equal to each other and then the other two sides are equal to each other. It's just that a square that all the sides are equal to each other. So that's why that works also. A rhombus is also, a square can also be a rhombus as well, going back to our notes. So let's check this answer option to see if we're correct. We are. Moving on. The next question says the pattern follows the rule quadrilateral with one set of parallel sides, quadrilateral with two sets of parallel sides, quadrilateral with no parallel sides, quadrilateral with one set, quadrilateral with two sets. Select the quadrilaterals that could be in the next three patterns. Click the icon to view the pattern. So I'm assuming that it's quadrilateral with one set of parallel lines, which is this one, quadrilateral with two sets, this one, this one, this one, this one. This is one set, this is another set. Quadrilateral with no parallel sides, so there's no sides that are the same. Nope. Then quadrilateral with one set again, so these two are the ones that are parallel. Then another one with two sets again. Sorry, right here, two sets again. These would be the next one with two sets of parallel sides. And then it's saying select the quadrilaterals that could be the next three in the pattern. So this is one. So it goes with one set, two sets, no sets. One set, two sets, no sets. Then it goes again for the next three after that. After no sets is one set again, then two set, and then no sets again. So let's see which option we can have. So we did the no sets already. It gave us the no set in the picture. Now we need one set again. Then we would need two sets. And then we would need no sets again. So it would need to be one set, two sets, no sets. This one is two sets, one set, one set. This one is no set, two sets, one set. This one is one set, two sets. So C looks like our option. We are correct. Okay, this next problem makes you think a little bit, and I like those types of problems because we do need to think a little deeply about what we're learning. So it says, Jarvis says every rhombus is a quadrilateral, which is true. A rhombus is a closed figure with four sides. Then it says every rhombus is a parallelogram. Well, that could also be true because a rhombus has two sets of parallel sides, meaning that the opposite sides are parallel. So every quadrilateral must be a parallelogram. Do you agree? Explain. I don't agree because there are quadrilaterals like a trapezoid that don't have opposite sides being parallel. So that means that it wouldn't be a parallelogram. It would be a trapezoid. Or it would be, trapezoid is the only one that comes to mind right now that don't have two sets of parallel lines, but they are quadrilateral. So I would say it's a no. It's not A or B because it's not yes. So let's see which no it is. Any quadrilateral that has less than two pairs of parallel sides is not a parallelogram. That's true because parallelogram means that you have to have at least two pairs of parallel sides. No, any parallelogram that has less than two pairs of parallel sides is not a quadrilateral. That's not true. A trapezoid is a quadrilateral. So C is our option. We are correct. I love a good pattern. So what number comes next in the pattern? The rule is multiply the position number by 5. Describe a feature of the pattern. So if I'm multiplying the position number by 5, that means that this is position 1, that 5 is in position 1, so 1 times 5 is what I did for that. This is position 2, so it would be 2 times 5, which is 10. Then the 15 is in position 3, 3 times 5. Position 4 is 4 times 5, which equals 20. And now position 5, 5 times 5 is going to equal what? 5 times 5 equals 25. So let's describe. Now, A says blank. Our fifth place is blank. A pattern is the numbers are all multiples of 3. That's not true because 5, nothing times 3 is going to give me 5. Nothing times 3 is going to give me 10. A pattern is odd, then even, etc. So it's saying that it should be odd, odd, even, odd, odd, even. That's not true because this is odd, this is even, this is even. No, this is odd, this is even. So it should be odd, even, odd, even. And then 25 would be odd again. The pattern is the numbers are factors of 10. That's not true because 15 times nothing is going to give me 10. Let's look at D. A pattern is the ones digit alternates between 5 and 0. Okay, that's true because this 5 is in the ones place, then the 0 is in the ones place, then the 5 is in the ones place, and the 0 is in the one place, then the 5 is in the ones place. Let's try this one. It's the only one that made sense so far. Let's check our answer. We are correct. Could you use a formula for finding the perimeter of a rectangle to find the perimeter of another quadrilateral? Explain. The formula for a perimeter of a rectangle is P equals length times 2 plus width times 2. Now let's think about a rectangle. And then let's think about a square. Because I know that the square and rectangles have similarities. Now, if we did the length, let's say this is the width and the width, and then the length and the length. We would be doing length times 2, width times 2, and we would add them together to get the perimeter. Now here, remember, a square means all the sides are the same. So let's say we had the width up down here and the width up here, and then length over here again, length over here again. That's fine. We can do this the same way that we did the rectangle, is just be that all the numbers are the same. So it wouldn't really matter. Now let's look at our options. With this being said, that means that yes, we could use a different quadrilateral and then also have that same equation to use, and it would make the same equation to use, and it would make it this correct way to get the perimeter. Now, with that being said, the no's here in our options are not going to be correct because we just proved that it's a yes, so we have to see which yes it is. Up here for A, it says, yes, you could use the formula to find the perimeter of a parallelogram because all parallelograms have 2 pairs of parallel sides with two different side lengths at most. When I say at most at the end, it's saying that you could either have the same sides or it would be 2 separate numbers because it can't be 3 or 4. It could be 2 at most. So it could be 2 different side lengths or 1 different side length. That's what it's telling us. So this one has an option of being correct. Let's look at D. Yes, you could use the formula to find the perimeter of a parallelogram because all parallelograms are also rectangles. That's not true. And that wouldn't even work for this option because they said another quadrilateral, not just parallelograms. So D is not the option because a square is not always going to be a rectangle, and parallelograms are not always rectangles because this parallelogram here is a square and it's not called a rectangle. So the option for us is A. Let's check it. We are correct. Moving on. Thanks again for joining us, super friends. I hope you learned something today. If you did, give us a thumbs up on this video. If you'd like to stay tuned for any upcoming lessons, feel free to subscribe. And as always, make today a great day. The choice is up to you. Until next time.